All right, well, we get going in a couple minutes. Almost there. I'm muted. Hope you're doing well today. It is me, Jared, again here with Zephyr 101, doing a session on LittleFS. So LittleFS is a great little embedded file system that you can use on microcontrollers with or without an RTOS. But in this case, we're talking about Zephyr's integration into their ecosystem, so you can basically use LittleFS without really thinking about much in terms of the lower level configuration and things like that. So that's what we're going to be jumping into today, and yeah, let's kick it off. If you haven't already subscribed, hit the subscribe button, hit that like button, hit the bell icon so you guys know when these sessions happen, because they're kind of random sometimes. Try to keep them weekly, but you know, things get busy. I also get inspired sometimes. Sometimes it's you need that inspiration. So unfortunately for this particular video, it was actually inspiration from one of our community members, and Livia was suggesting to make a video regarding configuration and usage of LittleFS on external flash. So we are going to do just that. LittleFS, so you can use it to connect, or you can use it to read and write from, for example, NOR flash, or you can use it for onboard chip flash. Something inside me says that you can probably also use it for something like an SD card. I have not played with that. I've usually used FATFS for that. So yes, Zephyr also supports FATFS, so you can read and write to an SD card and then pop out that SD card and put it into your computer and look at the files and look at the results, which is kind of cool. Very useful for something like logging, or maybe if you have bigger files that you're dealing with. LittleFS, so it uses the underlying file system APIs, so you can read, write, you can actually erase a whole disk if you want, but that's a little bit beyond the scope of this particular video. And the other cool thing that you can do is you can use it in Zephyr's settings subsystem. So Zephyr has a couple different ways to use settings. There's like kind of more of a simple file system access that you can use for your onboard flash. So if your microcontroller has a certain amount of onboard flash, you can actually allocate some of that for settings, configuration, things like that. Or you can actually use LittleFS. So it really depends. LittleFS, I think, is a little bit higher overhead. So if you don't have a lot of space on your onboard flash, then you probably want to use the kind of the default. I forgot the name of it. Maybe somebody will actually write it in the comments. But for something like NOR flash, it's perfect because it gives you, as long as you have a decently sized NOR flash, you'll have more than enough space to read and write files as needed, and also the overhead for all the maintenance stuff and things like that. So something to keep in mind. So what we're going to do is we're going to configure project configurations and overlays to make sure that external NOR flash is configured. And configure your project. So we're configuring things a bunch here. So it's gonna be a little crazy because I'm also gonna be showing 2 different ways to do it. So gonna make you guys confused. You can also, so we're gonna set up the LittleFS on the code side, so in your C files, and then we're gonna use the file system API to read and write. So configuration overlay, configuration in the .conf files. We're setting things up in the code, and then we're reading and writing, calling those APIs. And then Livia, you said I would try to use it for logging sensor data, and this is perfect for logging sensor data. I've done this on several projects now, so it's definitely something you can do. And I won't be going over exactly how I do it. This is more of kind of an introduction, but if you guys would like to see how I've done it, we can definitely do a video on it for sure. So I don't know if I have made that code public, but we'll see what I can do about that. This is what your typical overlay will look like. So, I mean, this is a WinBond part. This is actually the WinBond part on the NRF9160 Feather. And what we're doing is we're just associating it with a SPI bus. So then we're kind of configuring it in terms of size. And the DPD setting is a device power down. I believe that's what it stands for. One thing that's very critical, depending on the device you're using, is the JEDEC ID there at the bottom. That needs to match the device that's connected to your microcontroller. If this is not correct, you'll most likely get a JEDEC ID mismatch. So those are just the things you need to look at. That JEDEC ID is usually available in the data sheet somewhere. You might have to go. You might have to go searching. Oh, hey, Olivia. Hello. I mentioned you before if you missed it. You're my inspiration for today's video. So what we're going to do is move on here. So here's, this is basic. If you want to check it out, this is all. And I actually pointed to this or at least the example code in the description below, so you can check it out. You can also check out the Circuit Dojo NRF9160 Feather common DTS file, and it'll have this exact thing in it. Maybe let me see if I can add that. I'm going to see if I can 60 DTS. I think I can probably try to get this. Boom. All right. I'm just going to add this to this description as well before I forget. Click, clack, click, clack. So I've just updated the description with the link to the DTS file, so you can kind of see how it's configured. If you scroll down to the SPI bus there, SPI 3, it'll have that same exact configuration that I'm showing on the screen. So one thing that's a little bit different between NCS and vanilla Zephyr is, and you can do this too, depending on the chip you're using. So any of these fancier Nordic chips that have like the multi-core or the some of the more the security functionality. The thing is, Nordic basically has some scripts on the inside that kind of auto partition everything for you. And that's cool, but it also could mess with any type of external NOR flash that you might have. So it's actually kind of done for you if you have things configured correctly. But if you're using vanilla, you're actually going to have to kind of set up your partitions. So what I've done here is underneath the SPI bus, underneath the device, the NOR flash, you want to configure your partitions. So I've just created a LFS1 partition, LFS1_part. We're just calling it, LittleFS storage, and we're setting the size in bytes, I believe. And then, yeah. So that is for vanilla Zephyr. That's what I've done in the past. So, and this is also another thing that will throw you a loop. I believe you can do this on either version, so I don't think it matters that much. But what you can do is you can configure an FSAB. You can actually configure your file systems to be automatically mounted on boot. So Zephyr gives you the option to either you can kind of initialize your file system as need be in your application, or you can have it be done at boot time. So it just gives you some options in terms of if you care about it, if and when it gets initialized, or if you just want it automatically initialized on boot. So this gives you some set options. So this is just one way to do it. So, and this is on the NCS side. So the only thing we have to do, so we don't have to declare any partitions. We don't have to do any of this fsub stuff. You can if you want. So we're not doing any of this partition stuff, but we are declaring the part underneath the spy bus or whatever bus you're using. So all you're doing is just so you're setting the PM, so the partition manager external flash, and then we're just using the label name there. So what it's going to do is, by default, it's going to call that partition. It's going to kind of configure and set up that external flash with the partition manager. The downside of anything in NCS is that when you're using this, it will by default configure external flash as a secondary slot for the bootloader. So that is something we will be fixing in a second. So we're on to the configuration, and these are all critical and important, especially if you're using SPI nor flash. So you have to make sure you turn it on. I use a bigger layout page size. I think by default is 512. One gotcha that I've had in the recent past is that when I was testing, so I had a bunch of Z-tests that was using file system stuff, and I had not set that page size. And what happened when it would boot into the tests on the device itself and say, hey, this isn't a valid page size, I'm going to format everything. So every time I would switch between the two, it would format every time, and that was just kind of annoying. So just make sure not only it's the page size that you want it to be, but make sure it's synced across things like tests and things like that. So make sure you have flash enabled, flash map, flash page layout. Those are critical for things to work, and also the file system. So you want to make sure that you're actually enabling a LittleFS. So without that, you won't be able to use it. So very important. And then, of course, the little bonus here is that you can configure the settings subsystem to use the file system, and not only that, you can use it to use LittleFS. So as long as you enable LittleFS as a file system, you can configure it appropriately. So when all the settings are set in the FS directory that's set here, I think this is a little bit different than the default, because that's why I changed it. But I think there is a default if you guys just want to use a default. But that is it for settings. But I'll show you how to use the settings in a second if you're not familiar. And this is the more important part related to NCS in particular, is that by default this is turned on. So it basically sets its external flash to be used as the MCU boot secondary slot, and in this case we do not want that to happen. So all right, here's a bunch of gobbledygook. We're in the seed code now. So we've done all the configuration, we've done all the overlay, we've done all the project configuration. Now we're moving into actually like accessing the file system. So first thing you need to do is actually kind of create a mount point. And this is kind of calling the information from your overlay and just making it available to your C code. So this is kind of like the in-between between your overlays and your C code. And all we're doing is just we're referencing the important part is, like, we've labeled the file system LittleFS_storage. So if you see that flash area ID, that is the guy that is actually kind of making the connection between the overlay and your code here. So we're setting the mount point to LittleFS. That LFS actually has to match the settings here if you want to use settings, whereas you're using the file system backend as LittleFS. So just make sure things are matching, and then if you don't, then you'll have a fun time trying to figure out what's wrong. This is like the configuration part. I'll just take a step back here. The configuration part is probably the hardest. That's the part that kind of threw me for a loop when I first started playing with this. It's just like I was kind of confused. I wasn't really sure how things kind of fit together. I would like change the name of something and then it wouldn't work, and then I would change it back and it would be working. It's like, it's just hard. What I recommend is like I put a link to, I already mentioned it, but I put a link to the example that uses LittleFS for the NRF91 in the description, so you can kind of see how I did it. It's pretty much the exact same code here. So, and it should work on the latest versions of Zephyr and NCS. So this is the difference. So if you're using the fstab configuration, you actually can kind of call it and use this kind of instantiation. It's already going to be set up, so all you're really doing is just fetching that pointer to the mount point. It's not nearly as crazy looking as this guy, but you know, it makes it a little bit easier. And once you get that mount point, you're ready to go. You can read and write and whatever you need to do, because most likely it's already initialized on boot. But if it's not, so if maybe we're using the first configuration or the first setup method, then you can see we can mount with the fs_mount. You can NTN888, you messed me up, man. Your presentation has improved way much over the years, I think. More clear. That's good. I'm glad it's more clear. I'm trying. So the fs mount is for mounting the mount point. So you're providing that pointer to it, and you know, we're checking for errors, obviously. So that will actually allow you to access the file system, easy peasy. Another thing that you can do, so the file system also gives you kind of like statistics, so you can see, you know, how many blocks and what the file size and how many are free and things like that. So if you're interested in kind of that information, then you can definitely get that too as well. So opening the file, so you have to open a file before you can actually do anything to it, whether or not you want to read or write. So you would just use the file system, the fs_open. And one thing that you can do is you can definitely check out the documentation on the file system. Just go to the Zephyr docs and type fs or file system, and it should bring you there. I typically just find myself using the header files, because those are basically, it's the same documentation, just in the header file. So fs.h, that will kind of give you an idea of what some of these calls do. But there are some important flags here that during the fsopen call that you want to make sure that you're using, depending on your situation. You might want to append only, you might want to create and read and write. It really depends on your situation and what you're doing. I typically will either, if it's something that, so for logging and things like that, I will create and append and also read write. So it really depends on your situation here, but these are all the flags that you can do. You can see just read write is just the two read and write or together there, and then create and append. So you have some options here. And the cool thing is all of this is, so we went from like configuring down low level stuff related to LittleFS and just the partitions and North stuff, but all the magic is already taken care of for you through Zephyr. So all you're doing is just using the file system API, and many of you might have already used the file system API for different things in Zephyr. So this is an example of like reading. So there was an example somewhere in Zephyr or NCS or somewhere where you're just reading a simple 32-bit number, which is just like the boot count. So what this is doing is just reading. You're getting that value, and then you're seeking. So what seek does is allow you to reset the pointer in the file to wherever you want it to go. So in this case, we want to essentially rewind to the beginning of the file. So when you're reading, what happens is you read the file, and then the point, so you indicate the size. And what happens is once you read those bytes, so in this case, it's going to be 4 bytes, or however many bytes, 4 bytes, right? you're going to read those bytes, and then that pointer of where the last read occurred will stay there in that position in the file. So if you want to like move it back, if you want to write over that area, then you're going to have to use that fsseek. And this is good for if you want to read a file and you maybe want to do it chunk by chunk, then this is a great way to do it, because then you can be like, you can track that offset. So maybe it's something where you are reading a chunk, saving it, sending it off somewhere, and then you're coming back. You can save that offset and then reuse it in the next iteration. So useful for jumping to a particular place in the file and then continuing reading, especially if it's a kind of a big chunky file. On the FS write side, again, we're just writing to that boot count. And you can see that, I don't know if I included, so yeah, up here at the top tier, the struct fs file that t_t, that's the file pointer essentially, that once fs open creates a valid file, then that is alive for you to use it as the first argument in any of these calls. So we're using that first argument, the file, and then we're just writing back the boot count. Maybe it's just incremented by 1. In this case, in this example, in the one that I put in the description, that is the case. And then you can also use fs_close, and this will close the file as necessary. And I do recommend, once you're done with it, just close it. There is the ability in the file system to leave a certain amount of files open if you'd like to, but it is a limit, and it does take more memory as you use it. So there are some parameters in the file system configurations where you can increase that amount if you want, but I just leave it default because I usually leave things closed. There is some caveats, so I will say this. So there are some caveats in terms of, so I'll give you a preview of how I use this. So what I do is I have a specific type of sensor data or whatever, and I have a file that basically tracks. It's kind of like it's like a ring buffer-ish kind of, but it's in Flash. So what it'll do is you have these file names, and it tracks the beginning of the buffer and then the end of the buffer in terms of data points. So we have it tracks that one little file. It's usually just a structured piece of data. It says the beginning of the data starts at file A and ends at file 1, and then ends at file 3. So you know you have 3 data points. What happens is, if you're not careful enough, you might find yourself writing and writing to that kind of one map. I call it a map file. It just maps out where everything is, and it will kind of lock everything up because it's always reading and writing to that file. And reads and writes to Flash are expensive. I mean, it's not, especially if you have a process intensive kind of, if you if you have an application that's using the file system a lot, maybe it's reading and writing data consistently on millisecond basis. So you have to be careful about those consistent read and writes, because they will eat up time and they will slow down your application and you'll get frustrated. So you just got to be very careful. And when you're reading, or when you're writing in particular, but when you're reading as well, because it will chew up processing time. One thing that I do so just some tips here. So one thing that I do is sometimes I'll just take the basic structure. So you have a struct. Yeah, the struct has a certain amount of bytes. It's already formatted in a certain way that your application will, if it's read back, it'll know what it is. You can just keep using it. You can write that directly to disk if you want. So for instance, that map file, I know that the map file is not going to change at all. So, or that map structure, I should say. So I just write it directly and I read it back. The downside to that is that, you could have some corruption. Maybe that map file changes somehow, and then you try to read it out and it's not valid. So that's not good. You can actually put some checks in there and some sane defaults. So what I do is, maybe if I read it out and it doesn't make sense, or it's not the right amount of bytes, then I will use a sane default. Another thing you can do is, when you read and write to disk, you actually can you can encode and decode using a decoder. And sometimes I've done this with a CBOR. CBOR is great because it's very compact. You can do it with JSON if you want. It's a little bit more painful and more memory intensive and takes up more space. But there's a bunch of different options out there that you can do. I prefer Seaboard, but there are other different ones. But the cool thing is it's more robust against those changes. So say you have a change to your structure and you pull it out, you can kind of read it as the old version, or in most cases, the Seaboard is very forgiving. You can actually just read it out and then provide a default value for entries that are not in that particular structure. So what I use LittleFS for is storing. So I store timestamp data, so device data, so samples from over and over, like GPS coordinates. I have a device on my desk right now that's storing temperature, GPS coordinates, everything like that. I use it for storing configurations using setting subsystem. You can also just use it if you feel like just accessing it directly using LittleFS. You can also do that too. But it all, man, I can't talk all of a sudden. You can also use it for saving bigger and bulkier files, OTA images, or anything else that you can imagine that may be a little bit bigger. Images, if somehow you're capturing images, things like that. So, but remember, one thing that I'll throw another tip in. One thing that I also do is I set up a thread dedicated for accessing the file system. That way your main thread, your cloud threads, anything else is running on, because like I said, things take time with the file system. So you want a thread dedicated to reading and writing from the file system, so nothing else locks up in your application. That way it starts a write operation, starts a read operation, then it kind of yields to the rest of the system, and the rest of your system can continue running until that part of the code is ready to come back and be used again. These are just things that I've learned over the past couple of years of just like, oh, why is my code locking up? Why is the watchdog timer going off? It's stuck. It got reset because it was in the middle of a flash reset or a flash clear or flash erase. Like, let's fix that. So just some pro tips there. So configuration, well, in summary, I'm just summarize things here. So the configuration is probably the hardest part. It's the most confusing. It'll throw you for a loop. And especially if your Flash isn't the same Flash files or Flash devices that might be as examples in Zephyr or NCS. So for my particular chip that I was using, the Winbond WS W25Q32, whatever it is, whatever it was, the 32 megabit one, that was not available anymore. So I had to use the 16 megabit version to kind of go off of that and then change it over so I could use it that way. And then, make sure your overlay is correctly declaring, the mounting points and things like that. If you want to go as far as creating an F-stab so it actually mounts it automatically. What I recommend first is probably just getting it working, and then you can always add the F-stab later if you want to go crazy. And cool thing is, once it's complete, you can use the Zephyr file system API and not really think about it anymore, which is nice. So, and that's it. So if you'd like to subscribe at jaredwolf.com, I send out emails occasionally. I actually just sent out an email a week and a half ago. Had some deals on the NRF9160 Feather. So if you missed out, I'm sorry, but there'll be more coming very soon. And that's it for today. Let me see what I got in the comments. So let's see. NTN888, I'm going to resume where you kind of left off. So wouldn't mind if you actually redo some of the important Zephyr topics. I was literally looking at that today. One of my most viewed videos is actually getting started like your first build in Zephyr, and I'm sure it's terrible. So it might be worth doing again, for sure. And let's see. Mintasan, wonderful. Thanks. And then Livio, thank you. I'll try it when I get home. Yeah, I hope this helped you. It's the configuration part is a little confusing, so take it step by step. Use the basic samples, the ones, the file system samples. Use the one in the description below if you want. That one is literally the same. I think it's one of the same samples that Zephyr had, just tweaked slightly. So I hope it helps. So, but we've been going for over 25 minutes now. 32 according to my recording button. So that's it for today. And if you have any suggestions or comments, please leave them in the chat or the comment box below. Love to hear from you. A lot of these sessions, most of them are inspiration from the community. So if you want your question answered, just be like Livio and just send me a message, and I would be happy to cover those topics, especially when I feel inspired like today. So thanks for being here, and we will see you on the next one.